Hey, good morning, everyone. Hey, this is Jack Hu. I'm a process automation director in Dow. So my job, in short, is that we have been using human intelligence to automate our manufacturing site. So that's what I do. So now I would like to pass on first to Xiangping. Could you please introduce yourself?
All right. Hi, everyone. Xiangping Ko. I'm a senior architect with Dow. I enable digital transformation for manufacturing operations for safety, reliability, and productivity. To be here.
I'm Adam Williams. I'm the Senior Manager of Engineering Design Technology for Motiva.
Hi, everyone. My name is Ahmed. I work with Gecko Robotics, and my vision is to make sure that everyone here leverages our robotics and AI software to unlock value and get the data they need to make more important decisions.
Hi, everyone. My name is Diti Sood. I'm the founder and CEO of Bolo. I started my career with Schlumberger as a field engineer. So used to work in the Middle East in my hard hat, steel-toed boots, coveralls, working in the desert out of a truck, and then transitioned to AI and tech with the mission to use AI to make daily work faster, safer, and better for every heavy industry worker.
Hi, my name is Gulshan Oshan. I work for Kyndryl as a consult partner focused on energy and utilities sector. My background's in applied math and computer science, so AI and advances thereof are of particular interest in their applicability.
Hey, good morning. Tep Smith. I think my title there is the maintenance, deploying and developing the maintenance program for Chevron we call it the FIRM program. That's as of about a month ago, so I've switched over to opportunity shaping, so trying to understand from an operations and turnaround function where opportunities are and trying to pair and shape those opportunities and prioritize them.
Hey, thank you very much, and it's a very honor to moderate this panel. And to prove the point that transformation to the digitalization is needed, I bring a piece of paper. So I think the first question we have in mind is that the integrating the models and the human expertise. How can we combine machine learning, physics-based and rule-based approach to build AI system that reflect both data-driven intelligence and operator experience? So I think this one first goes to my dear friend Xiangping, and then we will pass the line. So thank you.
All right. So I think I'll say we have a lot of information out there. We have a lot of standards. We have a lot of people with knowledge, but those are in a person's knowledge. They're not accessible globally. So how do you make that information more readily accessible? So we see this as an opportunity for implementing some AI, like LLM technology, for answering ad hoc questions. Why LLM and some of these type of things is that it is better able to interpret the nuances of how somebody would ask a question better than if you could think about it in English, but you would see somebody in a different country asking the questions differently. So with that access to information, you're hopefully enabling that expert information to be available to anybody, anywhere. So.
Yeah, I think there's no one AI approach that we could make function all the way that we would like to, right? So the hybrid AI is what's key. The machine learning piece looks at the data and can provide results, predictive analytics on those pieces. The physics-based grounds it in reality. And then, of course, you have the rules that are going to be driven by the actual people that will define what those guardrails are to help drive what direction the AI needs to provide results so it actually provides value and can be trusted.
Yeah, I really like what you were saying, Adam. And I think when you think about AI and what its purpose is, it's supposed to enhance what you're trying to do based on real-world activities. And so if you only put physics-based models or data-based models separately and don't put them in conjunction with each other, it's not actually simulating what's going on in the real world. And so you have to input it with as much data as you can, quality data on a recurring basis, so it's able to make those predictions. Otherwise, you're filling yourself with too many assumptions, and then with those assumptions, when you're not getting the right kind of recommendations, that's when you go back and you default to rules-based. So it's about making sure you're providing it with the intel it needs, so it's making the decisions based on what's actually going on.
Uh, I obviously echo a lot of the points that have been said here. And then in the last panel, they talked about the point of just starting again from pain points and use cases and working backwards. One of the threads I've noticed over the last couple of years is there's this top-down mandate, we need to do something with AI. And people are like, we know AI is going to help us, we don't quite know how and what's the use case. And it almost seems like there's this, there's this shiny object, we want to do this check mark exercise, but it's not a good use of anybody's time because it's not adding value. So I think and it's something which probably is very obvious to everybody here, but we have the same pain points. We have assets we want to make sure have less unplanned downtime. We want to make sure everybody is safe. And then we have priority and value on what we need to do. And I think it's really starting there, working backwards on how you want to solve some problems. And for some things, physics-based models, simulations are the right choice. For some things, there's a lot of unlock that might happen with agentic AI solutions and generative AI solutions, which is what we spend a lot of our time thinking about, but not all problems need to have a chatbot on top of it. So yeah, all of that is a long-winded way of saying that all these things are there to help people do their jobs effectively. And it's really, I think, like any tech solution, like any project, looking at what is the objective we want to solve and working backwards. So that tech is just an enablement tool. So is people, so is change management. Yeah.
I think there's two aspects. One that's already been covered around having sort of a hybrid intelligence approach, where you have AI agents that are orchestrating ML-based, rule-based, and physics-based. But then I think the other important piece is to continue to have the human operator in the loop for the final decision making. So I think that's another key aspect of how you get the two to collaborate, to come out with decision making that also have the guardrails and safety built in.
I'm going to take a slightly different approach. So this has been kind of a journey for us at Chevron. So Chevron has traditionally been a very diverse group. All the BUs kind of ran themselves with SMEs embedded in the business units. And so everyone developed their own tools based on what the problem was of the day. So one of the first challenges for us was how do we centralize our engineering, our center, and then how do we centralize our data? So that's kind of been a journey for us. So trying to put like pumps and stuff as class and subclasses, so we're not calling widgets different things. And then the question then becomes, all right, what tool sets do we need to do analysis on those different pieces of equipment? What is good and bad? We don't care if the pump's upstream or downstream, the physics are exactly the same. So why do we have multiple SMEs looking through that data differently with different tools? So I think one of the things that we've been really focused on is how do we kind of group these things, and then, and traditionally the center has been very reactive. Usually we'll find out an incident happened when everyone else finds out on the news, right? So in a lot of cases there, how do we get those signals, those physics models, and then alert kind of the center and the SMEs at the same time, right? So I think we had to fix not only just, hey, how do you do the physics-based model, but how do we build and group these things? How do we do the understand physics, understand what's good and bad, and then everyone's getting that same signal throughout the enterprise, right? So again, it's not just the tools itself, it's the workflows, it's the people, and making sure that we're not flooding them with too many alerts, but at the same time, we want to do it the same way.
Hey, thank you for the excellent round of answers. So I really we emphasize the human piece out of it. So yeah, I also keep telling my team member, right? So even in this AI time, the domain expertise, which means human expertise, should be valued. Supply and demand, that always rules the market price. Okay, all right. So the second question is really dear to my heart, called the data foundation for AI success. So in our automation system, we have more than 10,000 data coming from the rolling plant. And every time when we really need it, it's either bad quality or timestamp is not accurate or here and there. So now, when we leap towards the AI, for the AI success, what are the main challenges in ensuring data interoperability and quality across complex refinery environments? And how can we organize sustained data consistency over the time? Goes to you, Xiangping.
All right, so the problem is not new. You probably heard data quality, data governance. You got to know what you're working with. So there's a myth out there that AI is smart enough to read through bad data and tell you good data. That's a myth. It still comes down to people understanding how the AI is coming up with the answer. So this comes in the form of checking the references it's getting from. If you want to have good data, unfortunately you still need good AI response. You still need good data. That's still fundamentally it. If suddenly you get an anomaly, you got to have somebody still thinking like this doesn't make sense. So the human intelligence still needs to be there. So the AI use is exciting, but you're still ultimately accountable for that decision you make with that information. So a lot of people would like to pass that decision to somebody else, but ultimately, if you're using that information, you're accountable for that action that you take. So I'm sure you'll hear more data governance topics.
Yeah, so for those of us that work in the manufacturing space, we know that this is all about data everywhere. There's lots of different places it can come from, all these different silos that are currently in place, and the systems that were put there decades ago, and they were never intended to talk to each other. So it comes in 4 pieces. The first one being data governance, putting rules around what data you need, data lineage, and being responsible for who needs what and when, so it can be readily available, right? And then the next piece is the metadata, ensuring that it is actionable and also that it is up to date. And so you're going to have data owners and data stewards that are defined as part of the business. The next piece is the APIs. You want to make sure that your tools can talk to each other, even if it requires creating some sort of mapping files to understand how these things correlate with each other, right? And the next piece is contextualization, right? We have to contextualize by putting that data linked to the real assets that we have at the site. So by having all those pieces in place, it becomes more reliable and trustworthy, allowing the people then to be the human in the loop with that data to make good, actionable, timely decisions, which ultimately helps prove the ROI of the AI business case.
I totally agree with what you guys are saying, and I think that's something we've noticed across industries, whether it's oil and gas, steel manufacturing, is the silos are evident, and the silos are evident over historical times, whether they've grown inorganically or organically, because most of the time functions are working in silos themselves. They wanted the data for themselves, for their function to operate more efficiently, to get more insights. Oftentimes they don't actually cross work with other functions until they need to, but it's not like a desire for them to work with other functions and see how the data is interconnected. The real benefit of AI isn't just to make kind of like guesses and recommendations faster, it's to find new recommendations that you haven't thought about, and those really only come down to when you're working as a cluster, as a group in a unit, as opposed to just finance by itself, CapEx by itself, operations by itself. It's when you combine all those things and then you make the best decision for a refinery, for example, that's when you can leverage AI to make better decisions, not just faster decisions. And for us, it's how do we connect the different layers together to make sure that we're taking a comprehensive approach for success, as opposed to like, we just made this one siloed function successful, but this came at a cost for suffering for a different function.
I would say that the data quality challenge, as Sean and Jack pointed out, that it's been there for a while, and I think the people who have lived it are living it, and that's it's just the reality of, you know, there's just as an industry, we have just so much data. There's just so much structured data, sensor data. There's so much documentation, and it's a way of working. So I wouldn't have any mind-blowing insights on how to deal with data governance and you know, how to make sure things are uniform across. I think the additional thing that I would like to probably highlight, which is different, especially when we think about the Gen AI and agentic AI solutions and how they might impact our industry. So obviously we've all used ChatGPT and Claude and all of these different things. The reason they don't work very effectively, or even Copilot, if you ask it something very technical about show me this PNID and something really deep into it, it'll kind of just throw random stuff. And that's because an LLM does not understand the industry context. Same goes with Agent, which are using these LLMs to a good degree to power them. So I think the only nuance now, which is just something to build more literacy around, is for LLMs, Gen AI, Agentic AI to really work for industrial applications. The really important thing is feeding in the right context, the right guardrails, because you can't, in our industry, you can't just make things up. 80% accuracy is really low, because if things go wrong, things can blow up. And then the last part is feeding in this semantic layer, which is actually a lot more important for applications to work really well for industrial use cases. So that semantic layer is feeding in the business logic, understanding the underlying data, the table schemas, understanding the vocabulary, where, for example, working with this Fortune 500 utility where there'll be different people saying different words, but it means the same thing, that they might call it probability of failure score, condition score, degradation score, but it means the same thing. So feeding that semantic layer, that becomes a really important thing on top of the, the continuous improvement that people have been doing around data quality.
So, the data quality issue obviously has been a perennial issue for quite some time, right? Even before AI was a buzzword. What I think AI has added in our ability to address data quality is, having agents that watch out for data drift, right? That watch out for anomalies, right? So that's an additional function that AI agents can provide to address data quality. Another trend that we've seen, is creating sort of addressing data quality issues in a more central manner. In other words, let's say creating a marketplace of similar data that has multiple uses across an organization. So you address quality in a central location, and then with a marketplace approach, it gets requisitioned by various business functions that require that data. So you centralize where you solve for the problem, you deploy agents to monitor for the problem. And then when you look at a more of a cross-industry view on data that is emanating for, let's say, components and asset types, there's that question on who owns that data, right? The manufacturer of that component may have performance data that's available, right? Your competitors might have incentive to share some of that data with you for those assets and those components. So data quality can also then be informed by, not just data that you have for those assets, but also, through the marketplace, as well as your competitors and as well as the manufacturers of those assets.
Okay, so I agree with everything here. I'm going to take a quickly different spin on this. And so we collect a lot of maintenance data, like work orders, stuff like this, and it's huge volumes. I think one of the things is the data quality has to be as good as the decision you're trying to make. And so the way I would frame it as, okay, an example, 160 million people voted in the election. How many people do you need as a sample size to represent 99.9 confidence level? And that number is like 15,000. Right. So in theory, if you had a good sample of 15,000 people, totally random, representative, you don't need to know the data quality for the full population, right? We could save a lot of money, but okay, that's a different issue. But in theory, how do you get the data size to support the decision you're trying to make? So you don't need to have perfect quality and data on everything. You just need to have the right sample size to support the decision you're trying to make. In some cases, that may be a bigger sample. In some cases, it may be smaller. But just something to think about, right? You don't have to get perfect data. And I think people always say that, like the data is bad, the data is bad. If I can get a right sample size to represent the larger population, that's the level of detail I need to solve the problem, right? So I think sometimes we get a little bit churned up on this, but again, I agree with the intent of the rest of the speakers.
Hey, thank you so much for the excellent answer, and I do agree. We have a lot of silos, we have a lot of layers, and then to enable the success implementation of AI, this is a foundations data quality, layers, silos, we have to resolve. So now, let's move to the next question. This one is a little bit, we need an interesting answer from you guys to encourage the people in the room for this activity. So we know as a human nature, it's fun to build something. It's probably also fun to destroy something, but it's not fun to maintain something, right? So the question is, how should we integrate production priorities and market price volatility into asset health, forecasting to develop predictable maintenance plans without undermining long-term discipline? So how we use AI to do a better predictable maintenance. So, Xiangping?
So, yeah, sitting next to you, I gotta always go first, huh?
Sorry about that.
So like that question, I was thinking about it, like from a manufacturing perspective, you're touching at least 4 silos of people that normally don't talk to each other. You're talking commercial, you're talking, I think maintenance in there, you have the plant in there. So like, how do they share their information easily? And then there's probably some rules around, I can't share margins easily, broadly, even though that is a very good decision point, because you want to know what you're actually gaining out of it. So the way we have to share the data, you can call this data governance, you can call this data security, but how do we want to truly transform depends on how your existing policies that need to sort of modernize in this new world, I would say. I'm not trying to blame the silos. Everybody wants to do their thing because that's a good thing. But at the end of the day, we got to decide how do we want to work with each other to sort of enable new value. And I'm not saying make data all widely available, but there's got to be a systematic process to try to make things, understand the value you're getting from and the risk you're taking, the cost to implement to enable that kind of solutions.
Yeah, very good, I agree. I also think, one of the biggest barriers here is probably just ensuring that we understand where our source of truth data is, right? We have level 1, level 2, level 3, level 4 data, and so you may have something that comes up and the piece of data exists in 4 different systems, and it matches in 3. And now we don't know which one's correct, and then something goes wrong, because we're spending the time chasing down where does the correct data live. And so by not just the data governance piece of, what the rules are around the data, but also defining where do I go for the data I can trust. To me, that is the key to making sure that these systems are able to talk to each other and can find good, reliable data so we can trust what we're getting. Because if we implement these systems and there's no trust, then they're going to fail.
Yeah, I think this is a great question. I've had an evolving viewpoint on this. So earlier in my career, I was leading subsea interventions in the Gulf of Mexico, now Gulf of America, for BP. And what that meant is whenever a well was sick and it wasn't producing or operating like it would, we would go in and intervene and bring it back online. And so what you noticed, there was a trend of the operations group just wanted to pump the well as fast as it could. And rightfully so, right? The crude oil was at a certain price, they wanted to pump it up and they wanted to make that money out there. And it's specifically true for refineries when they're looking at capturing kind of the market rates of, okay, well, this is a high rate right now that we can refine some crude oil and get these outputs, and that makes a lot more money, and there's a lot of margins to be caught. But what I've noticed now, and this is our favorite use case at Gecko, is that it's evolved into sometimes when you're running too hard, it's not actually a good financial decision for you in the long term. So it's understanding, okay, if I run too hard and my asset degradation happens to come at a faster rate, how does that look like for the next shutdown or the next turnaround? Or what about if I have my assets available sooner so that in case there's a fluctuation in the market rates, we can capture that? What we're noticing is there's a lot of margin capture that's left on the table because of equipment availability. And so one reactive decision to produce faster at a refinery might have implications down the road, not just on your maintenance schedule, but also on your margin availability capture. And so I think that's kind of been an involvement I've seen in downstream specifically, where they're looking at, okay, it's not just about the production capacity, but it's about the readiness of the equipment and how fast we can get it ready after a turnaround and a shutdown.
Yeah, and I think, Ahmed, to build on that, it probably comes down to just a lot of cross-functional communication and alignment, and I feel like a lot of people in this group probably are in roles which involve a lot of that cross-functional stakeholder management, and that becomes just so much more important. Where, yeah, the AI and tech is, I always say, like, that's a piece of it. The most important part is, again, what's the problem? Do you have the right people in the room? But yeah, I'm curious to hear Tap's perspective, because I feel like the owner-operators here, again, this is a problem you've been living for such a long time that your insights would be very valuable.
Want me to go first then? Yeah, so, well, this is interesting, right? Because, again, lots of databases, data everywhere. And to do it, it becomes a very passion project by some person. It's never systemic, right? And so I think that's one of the things that we want to fix. And so one of the things that we're trying to fix right now, I mean, who here knows what a pump curve is? Okay, who here has tried to take a picture of a pump curve and put it into ChatGPT? One person. It is awesome. It's a game changer, right? I've taken a operating pump curve with all the scatter plots of time, with the work order schedule on the bottom, with the seal temperatures and vibration. And 3 of them were time series, 2 of them were DP over flow. And I said, ask it, tell me about this. And it said, looks like you did a service on this date and improved the pump curve by this %. And looks like your seals have been going up. You might need to do something in the future, right? And so it's actually quite neat what visually some of these tools can do today without having to send it through a signal processor or something like that. And so I think some of these things are really cool, and I think evolving really, really quickly. And the reason I say that is I think we may need to start to use some of these tools to pull some of these databases together visually and test that out. It's actually quite neat. So again, I guess the question should be, hey, is it good or bad? It should be, what's my probability of getting to the next turnaround, right? I think we also need to frame the question correctly to match the data. So the question shouldn't be, should I change it? Tell me when it's going to break. That doesn't help me. Give me the probability it's going to make it through the next turnaround. 80%. Okay. Now I can make an informed decision, right? So the human still needs to be in the loop and something like that. But that's one way that we could figure out, and how do you combine the data with the human expertise and leveraging some of these tools. But anyways, so yeah, so I think really, really interesting, really excited about some of this stuff that's going on.
Okay, all right. Hey, thank you guys. So Tape, no relax yet, because next question goes to you first. Okay. Xiangping and I are friends at work. I just want to make sure he still talks to me, sit next to me when we finish this panel. So yeah, so the next one goes to the large language model. As a process automation, I really wish just to have a small language model first, because, hey, America, people want to see the HMI and the programming language in the automation space in English. Spanish, people want to see it in Spanish. Dutch want to see it in Dutch. Chinese want to see it in Chinese, but that alphabet is not supported by system. So that's the reality. But now we're talking about the large language models. How might the large language models reshape how engineers, operators, and the decision makers access and use information within industrial environments?
So we're using this quite a bit. And so a lot of the information we get is from operators. Turnaround notes, comments from why a well went down, work order descriptions, long descriptions. And a lot of it's unstructured, right? And you know that the moment that you put a drop down, other or don't know, or the first one on the list is going to be what they choose, right? So again, there's some human stuff. So I think one of the things that from the large language model is how do we start to make sense of all this data? I think we have like 5,000 incident in our databases. We got 6 figures of work orders a year. And we've got a whole bunch of reasons why things break just all over the place. And it's all free text. And so it's like, all right, if you send that to an SME and say, hey, here's a list of electrical person, please look at this. It'd be like, I don't know what I'm looking at, the data's bad. So I think some of the large language models that we're actually leveraging is how do we start to categorize some of these free text and unstructured data in a way that we can structure it and direct it to the right person to fix the problem, right? So I think that's one way we're really leveraging it, is to connect the problem statement with the SME that has the right information to fix it. We're doing this, and I think we're translating it from Kazakh, and we've got operations in Tengiz. So it is actually reading different languages and still categorizing it, right? I still can't read it, but at least it's categorized. Again, data issues, data quality is still something that we need to work through, but it's something that we are leveraging in the large language model space, and really, how do we get the right information to the right person, and then how do we do that in real time at the right time, right? So we're trying to figure those three things out. But large language models are really helping us out in that space. So something we just couldn't do because it's a volume problem.
Thank you, Dave. And now we move this line. So go ahead.
So I think large language models can act as a human conversational layer to your agentic AI, right? So I think a lot of that, and by virtue of that, one of the use cases that I've seen very commonly used is to use large language model to kind of safeguard and create guardrails for operational information that is shared, let's say, for field services or other use cases, where the LLM can make sure that the operator gets, the results of the informed data within the policy and safety and security guidelines and compliances. So it's sort of used as a conversational layer to create both safety guardrails as well as a layer of in front of an agentic AI platform.
No, I love this question. It's something I think about almost every day. I think it's in terms of how, one is there's this macro thing happening in terms of this new technology that all of us are starting to use. And there's these behavioral changes that we don't even realize are happening. So for example, your average Google search used to be like 2 or 3 words before ChatGPT. And now we're just used to asking questions in natural language that the average Google search is a lot longer. It's almost a sentence, tell me about ABC. And that's just how we're interacting with software in our personal lives, and that kind of bleeds into how we expect to interact with software in the enterprise. And I think where I see this going is the ability to interact with your data, ask your assets anything across the structured, unstructured data. So you can ask, okay, tell me which are my 2 transformers that are at risk for location ABC, and it can just flag that for you, tell you why it's coming from that. One of my personal predictions, which I'm willing to bet my money on, in case anyone is interested in taking that bet, is that probably 5 to 10 years from now, we would not be using static dashboards. It's just so painful to build all of these dashboards that just have one view, and then most of the times what people end up doing is just exporting that into raw Excel and slicing and dicing and then taking another export and merging that and building these pivot tables, because you as an engineer are trying to solve a particular problem. There are no 2 situations that are the same, that the same view works. And then we use Excel or the tools that we've been using forever to just come to that view that we want. And I think the ability to interact in natural language with your data to say, all right, just plot this time series, okay, just zoom into this one. It'll just basically make everyone a much more effective analyst without waiting for that one person who can configure a Power BI dashboard. So I do think that both on a personal level and then how these systems are going to evolve, the ability to interact with your data is going to lead to a lot more dynamic visualizations, dynamic, just setting up reports. Oh my God, when I was in the field, I feel like we used to write so many reports, and then I would write a report for my field, and then that'll go to my location manager, and then he will write one for his area manager, and then the segment manager, and there's just so much reporting, which again is something that you don't have to do in the same way. So I do think that there's just a lot of very interesting shifts that are already underway that we haven't even fully recognized, and I do think dashboards are going to be dead, at least the static dashboards.
So I'll caveat to say that I do use ChatGPT and Perplexity quite avidly, but I have a hot take on LLMs, and I think there's some research coming out that it's actually making us a little bit dumber as a society, because we're overusing it so much, and people are now just using these tools to communicate with each other in emails, and they're saying they're 40 to 50% more likely to forget what they just wrote. So you're emailing a colleague, and you're telling them, okay, here's what I think. The colleague is taking that, putting it into an LLM and saying, respond to this person, and they get back the feedback. And they don't even remember what they said to you, and then the cycle repeats. So it's almost making you a little bit more kind of like less able to focus and critically reason as a society. And so I think there needs to be really strong guardrails on LLMs so that it's not like diminishing society as a whole, because if you think about the generations before, they didn't have LLMs, so it was all inherent knowledge, right? And it's all knowledge that they are trying to transfer through LLMs to newer kind of operators and people to get up to speed. But if they're not actually learning the knowledge and understanding the pain that came with those learnings, the LLMs are essentially just repeating statistical analyses. And so if you don't have these guardrails, I think LLMs can be very dangerous, and trying to understand like why you're using the LLM in the first place is more critical to me than just getting the information faster. But again, I use it quite avidly, I know what it is, but if you start getting down a slippery slope of you're just gonna literally forget what you told somebody, and you have to remind yourselves of the conversations that you're already having through chatbots.
So I think it's important to look at LLMs as having multi-facets, right? So you'll have it as a chatbot, you'll have it as a query tool, and then you have it as a problem solver. And so there's different ways to approach it. There is do we allow it to search outside sources to provide feedback, and how trustworthy can we make that? Or do we build our own internal LLM that's going to be able to respond quickly with the information we want the users to get, right? And who provides that information, who trains it, right? So those are all keys to the LLM piece. Now, is there value to this? The answer is yes, right? There's a lot of low-hanging fruit out there for LLMs to solve, especially in the manufacturing space. One of them is like the document management space. I think the industry average is like 12 minutes for individuals in the manufacturing space to find documents that they're looking for, right? If you put all this information inside of an LLM, allow them a natural language search, that response comes back much faster and a much higher quality. Having supported EDMS initiatives in the past, I can tell you searching for tags or searching for keywords can return thousands of results that these users are having to scroll through to find the exact one that they're maybe kind of looking for, right? So having the ability to just say, this is specifically the problem I'm having, where does it live, and it can actually give you valuable feedback, that's something that's very helpful. Some of these user manuals we get from manufacturers are hundreds or thousands of pages long, and it's already pre-scanned all of it, so if it knows on page 53 it's going to give you the response you need, how much time did that save you, right? And what then can you do with that available time you had that would be a better use for the business, okay? So I think for LLMs there's a lot of value to it, but you also have to understand whether or not you're providing it with trusted data or it's data that you have to evaluate. And so the human in the loop piece of it that we've been talking all along about AI in general is key.
I'm going to go to like something Adam said the last time about if you get 3 production numbers, which one's the right one? And I'll say that they're right in their own context. There's probably some reason they were collected. Probably sometimes there's bad data too, but sometimes the systems are meant to collect, let's say production data. You have finished, you have semi-finished, you have raw. Sometimes if you want to capture all 3, they could be correct. If the LLM had that metadata nuance, and depending on your question, you can get different answers. Your numbers will be different, but it's up to your human intelligence to sort of interpret that what you're asking is what you're going to get back. So where I really like the LLMs these days is the ad hoc ability. If you create a dashboard, it has a certain lifespan to that dashboard's usefulness. It can answer a specific question until somebody exports it, reformats it, and then makes it ready for another use case. Whereas an LLM, you feed it data, you can ask it many different ways, many different questions, and if it had the context, it knew how to interpret the production data, it can give you new insights that you never imagined before. So that's the part I'm very hopeful for to where this is going. Some of our use cases, we started with use case A, but then you see how people ask questions. They're actually getting new insights that we never dreamed of before. Things that we can only imagine people ask, and then let's go spend time to build that dashboard. but people are asking it and they're getting the results they need. So that's the part I'm excited about.
Hey, thank you, Champagne. So now we are moving to the last question before we go to the poll question. So we start with TEP again. So now that's a famous MIT report, 95%. So in the downstream, what makes an AI use case investable enough to prove value, and what guardrails ensure we don't repeat those mistakes? In another word, how can we make sure we are that 5% in the MIT report?
Yeah, so again, I'm sure a lot of these people in this room have nails, and a lot of people selling hammers. And so I think part of it is, in a lot of cases, you know, we had a bunch of hammers going around looking for nails, and so sometimes it was solving the person's problem, sometimes it wasn't. Sometimes they built their own hammers because the other hammer wasn't good enough. So again, I think our focus has been on, hey, how do we focus the effort a little bit more? Because right now it's been passion projects, and you know, hey, this is really cool. And I saw something on one of the posters outside, which I thought was really cool, is what happens when your Gen AI goes faster than your governance. And I think we're kind of there right now, where governance is trying to catch up, and governance takes much longer because it involves people. But I think three things, right, is the way I've kind of framed it is, how do we make our SMEs more proactive rather than reactive, right? How do you get your data to tell someone that a problem's coming up, right? Because that's where the value is what decisions have you changed? We talk about ESPs, and hey, this ESP is going to fail in 6 months. The decision is, oh, well, I'm going to wait 6 months till it breaks, and I'm going to pull it and change it. And I didn't do anything different, right? So, great, I had information it's going to fail. You know, did I do anything different? So I think the first is, how do we encourage our SMEs to be more proactive rather than reactive, right? And say, hey, yeah, it broke, great, let's go fix it. And let's go find out why, do an RCA, and then we break it again. So how do we break that cycle? I think the second piece is really trying to focus on, a lot of people right now spend 80% of their time gathering data based on a reaction, right? So the way I would kind of frame it with our SMEs and is, how do you, hey, can I get you to give you the data, so you spend 20% of your time collecting the data, 80% trying to fix their problems or see it's coming. So again, I think you're still going to keep the same from a people perspective. We're not reducing people, we're just changing what they do. So instead of going in and doing data analysis, the data is there for them, and then they're able to spend the time adding the value piece, which is, let's do something different. And then I think the third piece of that was, give them the information to drill down, right? We give them a again, I hate dashboards, really do. Mainly because it's like, here's how the BUs are doing. I'm like, all right, so why? It's like, well, I don't know. So I think, how do you drill down, going back to the Allianz models, so that you can say, hey, here's all the variables that feed that, and then people can do a 5 why visually, would be really, really cool, right? Hey, I have problems with transformers. Why is it? Is it lead time? Is it, right? And then so you can drill down and give them the ability to drill down to the root causes, rather than building dashboards for the person who thinks what the root cause is, right? So kind of the three things. Sorry, probably too long.
I think that 95% failure rate number is quite shocking, right? So when I try to peel that back a little bit and say, you know, what could be attributed to that, given how easy and available AI use cases are, how easy they are to implement, I think part of the problem is the fact that they're easy to implement. Part of the problem is that there's significant choice, and I also feel that, you know, there isn't a framework that is available to kind of come up with a cohesive approach. In other words, we don't have the infrastructure necessarily to implement some of these in a consistent manner, and that's where the cost factor comes in, right? One dimension of that is obviously data, right? We spend a lot of time spinning around to make sure data quality exists, data acquisition and integrations exist into our models, right? So a lot of time, I think, is getting the right quality of information necessary to implement these models, right? The second thing is, you know, once these models are implemented, you know, it's an ongoing learning thing, right? I mean, once you develop a model, it's not just something you put on the shelf. you may get the results, but then the data set and conditions change that you may not have accounted for that may result for you to get back to the drawing board, right? There's additional cost of deploying the models, right? So I think that may go back to your point about making sure SMEs are involved right in the upfront in development of these models so they're more realistic and grounded. Second is making sure you have the right infrastructure and governance in place so that you're integrating the data quality and all those infrastructure elements in a manner that's cost effective and repeatable.
I think one area where I hope I think it's just something we'll get better with as we work with this newer AI tech stack is how do we measure success very tangibly in terms of what does success look like, what are the right metrics to track, and then how do we assign value to it. I feel fortunate that I started my career in the oil and gas industry, and then I live in Silicon Valley now, so I kind of see this whole new boom of how people are adopting AI technology. And one contrast that really sticks is when I speak with tech CEOs, whether it's startups or bigger companies, and how they view how they're using Gen AI agents, they're like, it is productivity, and I don't care that I'll have to hire fewer engineers, because I probably will not. It's that my output can be just so much more. Whereas I've had conversations with CIOs of really huge energy companies who've said, like, productivity is just too fluffy. That if you save someone 2 hours, what if that operator just drinks coffee instead? And I think there's this, that productivity, how we view that, there's a little bit of this shift which is required, because that 2 hours that is saved because they were not data wrangling, and that might be the most immediate thing that you can measure if it's a 2-month pilot, 3-month pilot, because you won't get to like failures avoided in 2 months or something much more meaningful. But it really, it's again going back to what was the problem that you were trying to solve, what are the leading indicators, where productivity is a leading indicator here, and then where does this really end? So it's working back towards what are the success metrics that you really want to be disciplined about tracking, and then having that forward-looking view where it's not like, no, tell me how this affects my P&L, do I cut people? It's more nuanced than that, and it requires a little bit more imagination and forward thinking, which I hope our industry gets to more.
Okay, so I'm going to sound a little bit of a cynic, but I'm not surprised about the 95% failure rate. What I'm surprised is why there was a failure rate. And if you go into the report and read why there was a failure rate, it's because the Gen AI pilots that were just launched like nonstop when ChatGPT first came out and LLMs were released were just implemented and sent out with no understanding of the workflow. So the majority of those failures came from not understanding the workflow and understanding the process that everyone is doing to understand what's going to happen. So I think historically in Silicon Valley and tech, initially what they do is they design software that would be very powerful, and then they would go and they would push it to these operators, refineries, and say, use this software as is and you'll love it. And that sometimes worked and sometimes didn't. Now I think what the new model is, where you're seeing with Palantir and others, is the forward deployed motion, where they're going out and trying to understand what it is that you're doing, to understand your workflow and your process, to see how their software could fit in. One acronym, or one kind of comparison I like to use is, I'm from Egypt, and if you want to go to the pyramids, it doesn't matter if you have a Lamborghini, you're not going to get to the pyramids. It's not going to take you through those sand dunes. So it doesn't matter if you have amazing software. If the software is not designed for the workflow in hand, it's not going to help you achieve your mission.
Yeah, and I think I'll be real quick because it looks like we're getting the signal here, but I think to be part of that 5%, it really comes down to just a couple of things. One of it is grounding it in the business use cases, making sure that people that are actually doing the work have feedback into the systems to ensure that it's actually what they need. And the other part is, instead of trying to calculate what your return on investment is going to be at the very beginning, instead start looking at what's it going to cost me if I don't do it.
Really quick.
Be realistic.
That's really quick. Okay. Hey, thank you guys, and I think thank you very much for this panelists. Please give them a round of applause. And